Welcome to this introduction to the Map Suite WMS server. In this video we're going to learn the basics of how the WMS server works and cover the sample applications. So for the agenda, we're going to answer the following questions. What is a WMS? Why use a WMS server? And why use ThinkGeo's WMS server? We're also going to review all the sample applications that ship with the product. So what is a WMS? WMS stands for Web Mapping Service. You can think of it as a protocol for serving maps over HTTP. The important part is that the requests are passed through the URL, so it's accessible, via web browser. It's also very easy to integrate into your applications. There's two main request types that are actually required. One is called get capabilities, the other one is get map. The get capabilities returns back some XML that tells you the capabilities of the WMS server. It'll tell you what layers are exposed, what styles are available for those layers, etc., and also some information about the server itself. And then the get map request type is kind of the interesting one, because in that one you pass it a bounding box and a size of the tile and the type of image you want back, and then it's going to give you an actual map back. Currently we support the version 1.1.1 of the WMS specification, and that's put out by the Open Geospatial Consortium, or the OGC, and I've included the link below. So why use a WMS server? What's the advantages to doing that? Well, the first one is that it's a proven standard. It's been in existence for a long time. It's very widely accepted. It also is very compatible, so there's lots of third-party tools that already integrate WMS. I believe Google Earth, all the different geospatial editors out there, just lots of third-party apps integrate with that. From a development perspective, why would you want to add a WMS server? One important part is that it centralizes your generation of maps. So let's say, for example, that you have some internal applications, and right now you might have the data being or the maps actually generated within those different applications. And with a WMS server you could centralize that. So you might have some desktop apps, you might have some web apps or some Silverlight apps. They can all point to one central location to get their maps. That also has the advantage of centralizing the security for it. So as you develop applications that consume maps, you don't have to build security into each and every application of how it's going to secure that data. It's also handy for the zero client deployment. So you don't have to send the mapping data with the application. And this is really important in the desktop scenario, because your data might be very valuable and proprietary. So what you can do is you can deploy desktop applications, have them point to a WMS server, and you don't have to worry about the clients having to download all the data, because sometimes the data can be hundreds of meg or hundreds of gigabytes. You can keep that all centralized. It also allows you to separate the map logic from the application logic. And what I mean here is that you might build an application. Let's say you're building two applications, a desktop application and a web application. If you render the maps in the WMS server and you encapsulate your rendering code there, then the different clients don't have to have that code in them. So the clients can really focus on the business case, and the map generation and how the maps look can be moved off to the WMS server. And so if you decide down the road that you want to give your maps a new and fresh look, you can do that in one centralized place in the WMS server, and all the applications will be able to handle that. From a hardware perspective, it allows you to scale the maps independently of scaling your application. And what I mean by that is generating maps is very processor intensive. It's also very disk intensive, and many times you might be able to build an application where two web servers might be able to handle 500 clients coming in. But once you throw map generation into the mix, it's going to take a lot more servers to be able to serve those clients. It allows you to separate those so that your application server might only require 2 physical boxes, but your map generation, you can scale that separately with different hardware. And so that moves into the next point with the hardware needs. You can scale those independently, and so you can get kind of a better return on investment because other applications that use those maps can use that shared hardware. So again, if you had multiple applications that use the same maps, you can take advantage of the shared hardware to generate them. So why use ThinkGeo's WMS server in particular? I think the first point really is performance. The WMS specification as it exists doesn't have any caching built into it because the way that WMS requests are made, you can specify any size of tile with any extent. And so what that does is it forces the WMS servers to always generate the data on the fly. Well, what we've done is we've included some caching logic into that so that when you use our ThinkGeo's WMS server with ThinkGeo's client, we can take advantage of caching, and that can really cut down the amount of processing power you need and the speed of which you can get these tiles to the client. Also, we've designed the WMS server to be asynchronous, and so it takes advantage of all the cores that you have to generate maps, and it's a pretty efficient design. From an extensibility standpoint, well, we have an API plugin model, so you design your the plugins or the different layers that you want using Microsoft's extensibility framework, and that actually is just a couple little tags that you put in your code, and then the server will load those plugins dynamically on the fly. So what this means is that as a developer, you just need to develop some plugins, drop those plugins in a directory, and the WMS server is going to take it from there. We've also included an extensibility model into the WMS server itself. So besides developing the plugins, you can actually get at some of the internals of the WMS server, and that allows you to add some things such as if you have a custom security model you want to implement, or you want to implement some sort of throttling that's above the plugin level, you can do that as well. And in fact, we have some samples that we're going to look at here in a few minutes that show exactly that. And also from an integration standpoint, we talked about this a little bit, but the tile caching aspect is supported in all of our ThinkGeo WMS clients. It's also supported in clients that aren't ThinkGeo, but it's supported in a little bit of a different way, and it's not as efficient, but you'll still get some tile cache performance benefits even if you don't use ThinkGeo clients. The other advantage is that you can use the Map Suite core libraries for doing your map rendering. So when you as a developer are creating your plugin, you can use the Map Suite core library. So you have access to the shapefile feature source or getting data from Oracle Spatial, PostGRE. You can use our styles, class break styles, value styles, etc. So you have all of that power. And another reason that's important is that if you already have an application and you want to move that application's rendering to our WMS server, it's pretty much just cut and paste all your old rendering logic and just move it into the WMS plugin, and you're pretty much done. The other reason is that typically WMS servers are pretty static. I mean, usually you set the layers that you want in the Git capabilities, and then the server just kind of renders that layer over and over again. And what we've done is that we've included in our plugin model a lot of dynamic application support. So if data is changing all the time, or if you want to have maps that are custom tailored by user ID or by situation, then we have a lot of little hooks in there that as an application developer you can create some very dynamic apps using the WMS server model. All right, so now we're going to cover the samples, and we'll switch over to that. All right, so what we're going to do is we're going to load the samples that come with the WMS server, and I'm going to load the 2008 samples here, and I'm going to pick the C# WinForms. Now note we're also going to have VB.NET, and we're also going to have Silverlight samples, but for this version we just have the 2008 and 2010 web and WinForms in C#. Before we get into running the samples, let's take a little time and investigate kind of the lay of the land here of what's included, because there's actually 3 different projects, and it's important to understand the relationship these projects have to one another. So we're actually going to start at the bottom, and we're going to take a look at the WMS plugin service. This is actually the web server that serves the WMS information, and it references let's see, the Map Suite core. It also references, the important one is this WMS Server Edition. So that's there. Now, if we look in the web config, the way this works is that when a request is made to this web service, there's a WMS handler that intercepts this request. And here we can see it right here. And this is the default WMS handler. That's what's referenced in the references. And it goes to ThinkGeo.MapSuite.WMS Server Edition.WMS handler, and that's going to get everything that has a WMS handler.axt extension. But we also have a couple of custom handlers, and these are for some of the different samples where we've actually overridden the handler. So it's important that if you override the handler, then you need to, create the the HTTP handler entries here, and these are for IIS 6. If you happen to be running an IIS 7 in integrated mode, then it's actually under a little bit different section, and it's right in here. Okay, so that's the first thing, that you need to make sure that the WMS handlers are hooked up. The second thing is the Get Capabilities XML, and for every different HTTP handler, there's a different capabilities XML that needs to be created, and you can just use these as a template. So, for example, here's the default one, and this is actually sent when the WMS client calls a Get Capabilities, and you can actually change a lot of this stuff. There's the address and the phone number and contact information, etc., etc. The rest of this is dynamically generated when the server is actually running and loads your plugins. But you just have to make sure that you have one of these for every WMS handler that you have. And just to note, under normal circumstances, you'd only have one WMS handler. You can use this WMS handler capabilities XML. You don't need to create your own custom ones, and you can just use that entry out of the web config. I'm just saying that if you get into an advanced case, you're going to need to copy that. All right, so what's going to happen is that one other thing in the web config is that there's a key here that specifies what the WMS layer plugin path is. And so here we just have a relative path called WMS layer plugins. That's where this project comes in. This project actually encapsulates all of your different plugins, and it's actually been the properties have been changed so that the build actually, instead of building directly to the bin, it builds into the WMS layer plugins of the service. And what this allows you to do is this allows you to debug the plugins while it's running. So the WMS server is going to start. The WMS plugins are going to get compiled. They're going to get piled into the WMS layer plugins. That's going to allow the WMS service to see those plugins. And then the last one is the actual client. So this is the desktop application that's going to run, and then it's going to consume these different services. So let's actually take a look here at one of them. Okay, another point is that when I started this, you notice that two things actually happened. I got the desktop application to come up, and then I also got a web page to come up. And this web page is kind of the server administration page. This just shows you all the plugins that got loaded. And the reason that both of these loaded is because in the solution, under properties, I set multiple startup projects. And so you need to have the WMS plugin service and the samples running at the same time. They need to both start so that when you put breakpoints in your plugins, the breakpoints will actually get hit. If you only started the desktop samples, you won't be able to debug through your plugins. So that's important. So here we're going to look at display a simple map, and all this is doing is it's using the Map Suite Desktop Edition to hook to our service and display a map. So to actually see what's happening there, we'll go ahead and stop debugging, and I'll kind of run you through what's happening. So the desktop sample app is starting. Let's see here, display a simple map. What we're doing is that we're creating a tiled WMS layer, and we're giving it this URI. And what we've done is for the server, we fixed the port so that the port's the same every time you run the sample, and we're giving it the handler name. So that's what the WMS handler is going to pick up on. We're going to give it the active layer name of display a simple map, because that's one of the layers that we've actually exposed. And we're going to set the styles to default. And every layer has a default style just by default. We're going to add that to the overlay, and we're just going to run it. So then what's going to happen is that when this application is running, it's going to make a request to the WMS handler. The WMS handler is going to then go to the plugin for display a simple map. And in the plugin, under this very simple scenario, the code is going to be called for get map configuration. And what get map configuration does is that it's called the very first time that that plugin is loaded for a particular style and a particular projection. And basically what this get map configuration allows you to do is it allows you to set up all the layers that you want to render and add it to this map configuration class or object. And if we look at map configuration itself, it has a collection of layers that you load in the layers, and then it has a tile cache. So if you actually wanted to take advantage of caching, you would create a file bitmap tile cache, set the tile cache there, and then it would start caching those tiles. So in this particular case, all we're doing is we're loading a world layer, we're giving it the country style, and basically that's it. You've also noticed that in this plugin, we've inherited this from WMS Layer plugin. So all the plugins you're going to use need to be inherited from that. There's also a couple overrides. We had a get name core. So this is where you need to return the name that we specified here in this layer name. And so this is what makes this particular plugin unique. You also need to specify the projection. And so this one is EPSG 4326, which is decimal degrees. And then you also need to specify a bounding box. And so you need to specify the get bounding box core and return a rectangle. So if we put a breakpoint in here, what we'll find is, go ahead and run this again. We'll go to display a simple map. We're going to get a breakpoint. It's going to run through here. Now, we're going to generate a whole bunch of other maps, but you notice that it's not coming into this request again because it's actually cached this now, and it won't call this again. Now, this is good for very simple maps that are static. We're going to look at some other different plugins that are very dynamic, and they work a little bit differently. Let's go ahead and stop that. Breakpoint out. Okay, so actually let's run the samples. Another thing you need to do is, because this is using MEF and it loads it into the web server, you need to stop the web server between debugs. So we'll take a look at some other samples. Now, some of these samples are a little more complicated, and we might just cover them on separate videos, but I'll give you kind of the high level, and then you can take a look at the code yourself. In this particular sample, we show how we can create our own, we can override the WMS handler, and we can add some verification. So in this sample, we actually sign the request that's coming to the server, and in that way we can validate it, and we can know from a security standpoint who the user was that made this request. So this is kind of the foundation of some security that you can include in WMS. So in here, in this particular sample now, we're including the signature so we can see everything, and we can also not include it, and we're going to get a failed authentication. Another thing that's pretty popular is doing throttling. And in this particular sample, we throttle the request so that you can only have 25 requests per 10 seconds. And in this sample, we've also done some customization to the WMS handler, and that's these two guys down here. And so if we pan around very slowly, we're okay. But if we start to pan pretty aggressively, then we're getting limited. And we draw out here that we're limited 25 tiles per 10 seconds. And this is request number 52, 53, 54, et cetera, et cetera. And so if we sit there for a little while, then, of course it clears out. So this is a way that you can do throttling. The log server request isn't finished yet, but that's just going to be a sample where we can show you how to add some logging by overriding some certain methods. So this particular sample is for dynamically drawing on the map, and this is actually one that we should probably go and look at the code, because it shows maps that have a little more dynamicism to them. So in this particular sample, what we do is we're drawing a watermark on the map, and you can see watermark on top of our other watermarks. And from a code perspective, the way that we do this is, let's see here, which one is that? Draw dynamically on maps. So we have the get map configuration, which you're already familiar with, and so here we loaded the map, and like I was saying before, this gets called only once, the very first time the map's requested. Now we also overrode this get map core, and this get map core is actually called every single time a tile is requested for this particular plugin. So what you get passed in for the get map core is you get the get map request object, and if we look at that, we're going to get things from the requesting URL, like what's the bounding box they're requesting, the projection, any custom parameters, the height of the tile, the layers that they requested, the styles, and the width of the tile, etc. We also get the map configuration, which is what we defined up here. So if we want to make any changes to the map before we actually draw it, we can do that. And then we get the HTTP context. And so in this particular example, to draw the watermark, we first call the base, a get map core, which returns a bitmap, and we pass in all this information. So we get the bitmap that's going to be generated, and then we create our own GDI plus GeoCanvas, and we actually do some draw text on top of the image. So here, if you wanted to do your own image drawing, you don't even need to call the map core. If you wanted to make some changes to the configuration because maybe it's a particular user, you can do that in here. And so this is going to get called every single time. So if we put breakpoints in here, and you'll kind of see what I mean. So now we go to dynamically draw on the map, and the first breakpoint's going to be up here. We're only going to get that once, and then here we're going to get it, for every single tile that comes in. It's going to draw the watermark. So that shows a little bit more dynamic, and then even a little bit more dynamic is the change style by user. So in this particular case, we have 3 users that we're showing here. So user number 1 has the map that looks like this. User 2, the style is slightly changed, and user 3 has a very different style. And the way that we accomplish this is we'll take a look on the client side, show specific user map. And what happens is that as we change the selected index, we go to that tiled WMS layer and we add an additional parameter called username, and we include what that parameter is. So as this tiled service is making requests to the WMS server, that extra parameter is going in there. So then that parameter is then passed to our plugin, which is show user specific map. So here's the get map configuration. This is the part that's static, that's setting up all your layers. And then in the map core, we're actually able to just go right to the request and go right to the query string, pull out the username, and then based on the username, we actually modify this map configuration to slightly change the layers, or in this case, add or remove layers. And then we go ahead and call the get map core for that. So, in this particular case, we can put a breakpoint in here. Let's see. Oh, I think wrong sample. So in this particular case, it's coming down here, and we've got user 1, and so this is just for all the tiles that it's requesting for that extent. And then if we pick user 2, then it's going to come down here and get user 2's configuration. And we have actually two samples that kind of deal this. One is change style by user, and that was the sample that I meant to put the breakpoint in, and that's where we just kind of change the style. But then we have another one that show user specific maps, and this style we're actually going to be modifying a little bit, because one of the other things that you can do and that's popular is that sometimes users can modify data, and so you might want to have a set of base maps, but then you also want to have areas that the user modified. And so in this particular case, you could actually go in and by user, you could inject new data into those layers that's specific to that user, and then it'll generate a map that's specific to them. The get data from custom sources, we don't have that one complete yet. The simulate vehicle tracking, this one's kind of interesting because what this does is that it uses the WMS layer from the World Map Kit as the background, and then it has another WMS layer that just represents these two vehicles. And so we'll put this on auto refresh, and every 3 seconds it's going to update the location of these, and it's going to call the WMS server every 3 seconds to get the current location. And of course, we can zoom around and zoom out. And what's happening behind the scenes in this is that, let's see, let me stop this, is that this is taking advantage of that get map core. So every time a request is coming in, we're actually updating the location of those vehicles based on an in-memory feature layer. But one of the other uses for this, of course, we're using in-memory feature layer, and we have kind of a stock group of points that it cycles through. But in the real world, what you would do is inside of this get map core, you might make a call out to a SQL server to find out where these actual vehicles are, load those up into the in-memory feature layer, and then call into the base to actually do the drawing of the image. So the take-home point of this is the get map core is where kind of all the dynamicism is, and that's where you want to put your code if you need control over every time a tile is generated. I think that pretty much covers the basics. Now there's lots of code here in the throttling to be able to create your own WMS handler, and in the secure WMS handler. So definitely take a look at the samples. We have a quick start guide that'll take you step by step in creating your first projects, and there's also the discussion forum, get out there and ask questions, develop your own plugins, just give us as much feedback as possible. This product is in beta right now. We'd love to have your input. Thanks.